Good morning, Sir Gomeliares. This is our report on the topic counting techniques and probability. Probability. Probability is the chance or prediction of happening of an event. While working with probability, we must know about the sum terms such as event, sample space, experiment, like events, complementary events, and mutually exclusive events, etc. Um, ang posibilidad daw ay isang pagkakataon ng hula na nangyayari sa isang kaganapan. Habang ginagawa ang posibilidad, dapat nating malaman ang tungkol sa ilang mga term na tulad ng kaganapan, halimbawang puwang, eksperimento, tulad ng mga kaganapan, mga pantulong na kaganapan at kapwa-eksklusipong mga kaganapan at iba pa. Probability is a measure of the likelihood of a desired events happening. So, ang posibilidad ay isang sukatan ng posibilidad ng isang nais na mga kaganapan na nangyayari. Means the chance or the likelihood of occurrence of an event. It is a numerical value that is lying between 0 and 1. When the event is impossible, probability of occurring that event is 0. When the event is sure, probability of occurring that event is 1. And all other events will have probability between 0 and 1. So, probability nangangahulugang ang pagkakataon o ang posibilidad ng paglitaw ng isang kaganapan. Ito ay isang numerong halaga na namamalagi sa pagitan ng 0 at 1. Kapag ang kaganapan ay posibleng mangyari na ang pangyayaring iyon ay 0, kung ang kaganapan ay sigurado, ang posibilidad na maganap ang kaganapang iyon ay 1 at lahat ng iba pang mga kaganapan ay magkakaroon ng posibilidad sa pagitan ng 0 at 1. The probability distribution is the distribution table formed to obtain the occurrence of each event in the sample space. From the probability distribution table, we can find the mean, standard deviation, and expected value. So, ang pamamahagi ng posibilidad ay ang talahanayan ng pamamahagi na nabuo upang makuha ang paglitaw ng bawat kaganapan sa sample na puwang. Mula sa talahanayan ng pamamahagi ng posibilidad, mahanap natin ang ibig sabihin, karaniwang paglihis at inaasahang halaga. Experiments and random events. In probability theory, random experiment means a repeatable process that yields a result or an observation. Example, percentage of calls dropped due to errors over a particular time period. Example number 2, the selection of a numbered ball 1 to 50 in a yarn. Sa teorya ng posibilidad, ang random na eksperimento ay nangangahulugang isang paulit-ulit na proseso na nagbubunga ng isang resulta o isang pagmamasid. Halimbawa, ang porsyento ng mga tawag ay bumaba dahil sa mga error sa isang partikular na tagal ng panahon. Halimbawa number 2, ang pinili ng isang may bilang na bola 1 to 50 sa isang rule. A random event is an event that either happens or fails to happen as a result of an experiment. When tossing a coin, the event or heads may happen or may fail to happen. So, this is a random event. On the other hand, if we consider the event, the coin falls down, we observe that this is a certain event due to the gravity. So, ang isang random na kaganapan ay isang kaganapan na maaaring mangyari o nabigong mangyari bilang isang resulta ng isang eksperimento. O kapag naghuhugas ng isang barya, ang kaganapan ay maaaring mangyari o maaaring mabigo na mangyari. Kaya ito ay isang random na kaganapan. Sa kabilang banda, kung isaalang-alang namin ang kaganapan ng barya ay nahulog, sinusunod namin na ito ay isang tiyak na kaganapan. dahil sa gravity. A random event depends on the combined action of several factors which may not have been taken into consideration when setting up the experiment. When tossing a coin, such factors may be the way we move our hand, the characteristics of the coin, the position of the coin in our hand. So, ang isang random na kaganapan ay nakasalalay sa pinagsamang aksyon ng maraming mga kadahilanan na maaaring hindi isinasaalang-alang kapag nagsiset up ng eksperimento. Kapag naghuhugas ng isang barya, ang mga naturang kadahilanan ay maaaring ang paraan ng paggalaw ng ating kamay, ang mga katangian ng barya, ang posisyon ng barya sa aming kamay. Certain event, possible event. There are two special events for every experiment, the certain event and the impossible event. The certain event, denoted by S, is an event which happens with certitude at each repetition of an experiment. When tossing a coin, the event, one of the two faces appears, is a certain event of the experiment. When rolling a die, the event, one of the 6 faces appears, is a certain event of the experiment. The impossible event, denoted by 0, is an event which never happens in a random experiment. When extracting a ball from a box which contains only white balls, the event, a red ball is extracted, is an impossible event. So, mayroong dalawang mga espesyal na kaganapan para sa bawat eksperimento. Ang ilang mga kaganapan at ang posibleng kaganapan. Ang tiyak na kaganapan na isinaad ng S ay isang kaganapan na nangyayari na may katiyakan sa bawat pag-uulit ng isang eksperimento. Kapag naghahagis ng barya, ang kaganapan, lilitaw ang isa sa dalawang muka, ay isang tiyak na kaganapan ng eksperimento. Kapag nagsama ang isang dice, ang kaganapan, lilitaw ang isa sa 6 na muka, ay isang tiyak na kaganapan ng eksperimento. Ang imposibleng kaganapan na isinalarawan ng 0 ay isang kaganapan na hindi kailanman nangyari sa isang random na eksperimento. Kapag kumukuha ng isang bola mula sa isang kahon na naglalaman lamang ng mga puting bola, ang kaganapan, isang bola ay nakuha, ay isang posibleng kaganapan. Contrary events. In the case of rolling a die, let's denote by A the event consisting of the appearance of one of the two faces, 2 or 5. An event B, the event consisting of the appearance of one of the faces, 1, 3, 4, or 6. We observe that if the event A does not take place, then the event B takes place, in the other way around. The contrary of an event A is an event B, satisfying the property that at any repetition of the experiment, if the event A occurs, then B does not occur, and if the event B occurs, then A does not occur. The events A and B are also called mutually exclusive events. If B is the contrary of A, then A is the contrary of B. We denote the contrary of an event A by A or CA. So, sa kaso ng pagliligid ng isang die, tukuyin natin sa pamamagitan ng A ang kaganapan na binubuo ng itsura ng isa sa mga muka na 2 o 5. At B ang kaganapan na binubuo ng itsura ng isa sa mga muka na 1, 3, 4, o 6. Naobserbahan na namin na kung ang kaganapan A ay hindi maganap, pagkatapos ang pangyayaring B ay magaganap. At sa kabilang banda, paikot ang salungat ng isang kaganapan A ay isang kaganapan B na nagbibigay kasiyahan sa pag-aari na sa anumang pag-uulit ng eksperimento. Kung ang kaganapan A ay nangyayari pagkatapos ay ang B ay hindi nangyari, at kung ang kaganapan B ay nangyari pagkatapos ay ang A ay hindi nangyari, ang mga pangyayaring A at B ay tinatawag ding mga pang-eksklusibong kaganapan. Kung ang B ay salungat sa A, kung gayon, ang A ay salungat ng B. Isinasaad namin ang salungat ng isang kaganapan A ng A o CA.
Compatible events. Incompatible events. The events A and B are compatible if they can occur simultaneously. When throwing a die, the event A, an even number, appears, and the event B, one of the numbers 2 or 6 appears, are compatible. If the outcome of the experiment is the appearance of the phase with the number 2, then both events A and B take place. The events A and C are incompatible if they cannot occur simultaneously. When rolling a die, the events A, an even number, appears, and C, an odd number, appears, are incompatible. They cannot take place at the same time. One may notice that the events A and C are contemporary events. On the other hand, if we consider the event D, the number 5 appears. We can see it A and D are incompatible, but they are not contrary events. The non-occurrence in A does not imply the occurrence of D. The events A1, A2, and are incompatible if they cannot occur simultaneously. When throwing a dice, the event A1, one of the phase 2 or 4 appears. A2, one of the phase 2 or 6 appears. A3, one of the phase 2, 4, or 6 appears, are compatible if the outcome of the experiment is appearance of with the number 2, all 3 events take place. Example of compatible and incompatible. If you roll a typical dice and event A is to roll a 1, 2, or 3, and event B is to roll a 4, 5, or 6, then events A and B are incompatible. Events implied by another event. We say that the event A implies the event B, or the event B is implied by the event A. If the occurrence of the event A means that the event B occurs as well. When throwing a dice, the event A, one of the phase 1 or 3 appears, implies the event B, one of the phase 1, 2, 3, or 5 appears. Any event implies the certain event. Example, getting a tail when tossing a coin, rolling a 7 with 2 dice. Operation with events. The study of occurrence of an event actually analyzes the occurrence of a part of the sets of elementary result of an experiment. When rolling a die, the study of the occurrence of the event A, one of the phase 1 or 3 appears. Actually, analyze whether we obtain one of the result 1 or 3 from the set of elementary events 1, 2, 3, 4, 5, 6. The event A is completely determined by the sets of formed by these 2 elementary results, and we can identify it by A equals quantity 1 and 3. Consider the experiments in which 2 dice are rolled. We are interested in the event A. The sum of the numbers of 2 dice is number 7. We look at the following elementary events, and we rewrite as the following sets. A equals quantity 1 and 6, 2 and 5, 3 and 4, 4 and 3, 5 and 2, 6 and 1. That's what we call the sets. The sets which represent the impossible events which never take place in our experiment is the empty set 0. The certain event is represented by the set of all elementary events. If A is a set of results which represent an event, then the sets A, the complementary of A, is the set of the results which represent the contrary event. We have seen that the fact that the event A implies the event B means that whenever A takes place, V takes place as well. Therefore, the set of results representing the event A is include the sets of results representing the event B that A union B. The sets representing two incompatible events are disjoint. Definition: the union A union B of two events A and B is the event which takes place when at least one of the events A or B occur. Example: for the experiment of rolling one die, let's consider the following events. The event A occurs if the one of the following result is obtained: set 1, set 2, or set 5. The event B occurs if the one of the result set 3, set 4, or set 5 is obtained. To ensure at least one of the events A or B take place, we must obtain one of the result. Set 1, set 2, set 3, set 4, set 5. Therefore, A union B is equals the set of 1, 2, 3, 4, 5.
Manceras Terez, and I am about to report my assigned topics, which are probability of an event, union of an event, how to solve a probability word problem, and independent events. The probability of an event occurring is intuitively understood to be the likelihood or chance of it occurring. In the very simplest cases, the probability of a particular event A occurring from an experiment is obtained from the number of ways that A can occur divided by the total number of possible outcomes. In probability also, the set of outcomes from an experiment is known as an event. So, say for example, you conduct an experiment by tossing a coin. The outcome of this experiment is the coin landed heads and tail. This can be said to be the events conducted with the experiment. Here we go. Let's consider the experiment of tossing a coin on the sample space A, which includes the two possible elementary results of this experiment, which is H is equal to the outcome of heads and T is equal to the outcome of tails. That results A is equal to H and T. As these two events H and T are equally possible, it is natural to estimate or to measure the chance of occurrence of each of them by 1 over 2 is equal to the inverse of the number of elementary events from A, which is the relative frequency 50%, over 1 over 2 of each of the two events. We consider the experiment of rolling a die and the associated sample space, which is A is equal to 1, 2, 3, 4, 5, and 6. As the 6 events are equally possible, it is natural to evaluate the chance of occurrence of each of them by 1 over 6, which is equal to the inverse of the number of events from A. Let's proceed to the finding probabilities in events. For finding the probability of independent events, we simply multiply the probabilities, while for finding the probability of dependent events, we either find the probabilities before multiplying by good analysis or by using the conditional probability. For example, 2 cards have been drawn from the deck of 52 cards without replacing the first one. Find the probability of getting first card as king and second as queen. Solution. Clearly, the two events are dependent. So, let A is equal be the event of drawing the king first. So, P of A is equal to 4 over 52. Now, 1 card is drawn already, so we are left with 51 cards only. And then, let B is equal to be the event of drawing a queen next. So, P of B is equal to 4 over 51. Now, the compound probability is given by P of A and B is equal to P of A multiplied to P of B, which is equal to 4 over 52 multiplied to the 4 over 51 is equal to 16 over 2652 is equal to 4 over 666. So, the probability of choosing a king, 400 4 is equal to 663. So the probability of choosing a king and then a queen is equal to 4 over 663. Random experiment and event. When something happens, it is said that an event has occurred. All the events are always associated to some random experiments. For example, flipping a coin is an experiment, and getting a head or tail are two events which are associated to this experiment. Complementary events. In probability, the complement of any event is the not that event. In a random experiment, the outcome must occur in every trial, and the probabilities of all possible events must total to 1. The probability of complement of an event must be unity minus the probability of an event. For example, we have an event B, and then its complement is not B. It is denoted by B over C, B over 1, or by a bar over segment B. Formula. The probability of event B is given by P of B, and the probability of its complement by P of B to the power of 1. In general, this is to remember that the total event of two complementary events is always equal to 1. That is, P of B plus P of B to the power of 1 is equal to 1. Thus, the probability of complement of event B is given by P of B to the power of 1 is equal to 1 minus P of B. Examples of complementary events associated with different experiments. First, the occurrence of the odd or even numbers when we throw a dice. Second, when we flip a coin, the occurrence of head and tail are also complementary events. Third, for a given basket of fruits and apples or oranges, picking an apple or orange are again complementary events. To find out the probability of an event also, sometimes we use the complement event probability for easier calculation. Space. The sample space plays a very important role in finding the probability of an event associated with a random experiment. Sample space is a term associated with probability theory. In an experiment or in a random trial, when we make a set of all the results or outcomes that are possible in the experiments or trial, that set is said to be sample space of that particular event. Example, when we flip a coin, there are only two possibles, either to get the head or a tail. If we present head by H and tail BT, then the sample space of the experiment of flipping coin says S is equal to H and T. To find the probability of any event associated with a random experiment, we divide the number of outcomes of that event with the total number of possible outcomes of the whole experiment, that is the sample space. Here's the formula. P of event is equal to number of outcomes of the event over number of outcomes of the experiment. Let's proceed to the general sample space. Commonly, we use the sign of universal set. An experiment can have more than one sample space depending on the condition being set. For example, if we see a deck of cards, we have numerous possibilities of sample spaces for the event of choosing a card. A card can be drawn and classified on the basis of its suit. Picking an apple or orange are again complementary events. To find out the probability of an event also, sometimes we use the complement event probability for easier calculation. Space. The sample space plays a very important role in finding the probability of an event associated with a random experiment. Sample space is a term associated with probability theory. In an experiment or in a random trial, when we make a set of all the results or outcomes that are possible in the experiments or trial, that set is said to be sample space of that particular event. Example, when we flip a coin, there are only two possibles, either to get the head or a tail. If we present head by H and tail BT, then the sample space of the experiment of flipping coin says S is equal to H and T. To find the probability of any event associated with a random experiment, we divide the number of outcomes of that event with the total number of possible outcomes of the whole experiment, that is the sample space. Here's the formula. P of event is equal to number of outcomes of the event over number of outcomes of the experiment. Let's proceed to the general sample space. Commonly, we use the sign of universal set. An experiment can have more than one sample space depending on the condition being set. For example, if we see a deck of cards, we have numerous possibilities of sample spaces for the event of choosing a card. A card can be drawn and classified on the basis of its suit that the sample space will be diamond, club, heart, spade. Or it can also be classified on its number, and the sample space will be the ranks and cards from 2 to 9. So we see that only in the basis of requirement as an experiment, a sample space is a set for that particular event of an experiment. Sample space examples. Let's have example number 1. Let us suppose we are flipping 3 fair coins together. Find the sample space and favorable outcomes for at least 2 heads. Solution. Sample space, we have S is equal to HHH, HHT, HTH, THH, TTH, THT, HTT, and TTT. Favorable outcomes for at least 2 heads. Favorable outcomes for exactly 2 heads and favorable outcomes for more than 2 heads. We have S is equal to HHH, HHT, HTH, and THH. Let's proceed to the union of events. An event is something that has happened and is always associated with an experiment. There are different operations performed on events. Union is one of them. As the name implies, union means joining of 2 things irrespective of their individual behavior. The union of 2 events gives us a compound event. For example, if we are performing the experiment of throwing a dice, then there can be numerous events associated with it, one of which can be the number on top be a multiple of 3. Formula. Suppose A and B are 2 events associated with a random experiment, then the union of A and B is represented by A union B. The probability of union of 2 events is given by P of A union B is equal to P of A plus P of B minus P of A intercept B. Here, P of A is the probability of event A, while P of B is the probability of event B. Also, P of A intercept B is the probability of the intersection of events A and B. Let's have now the basic probability rules. First, probability is obtained by dividing the number of possible ways of achieving the desired event by the total number of possible events. Second, since the total number of events is always equal to or larger than the desired event, probabilities are always a number between 0 or 9, or 1 rather. In probability rules, we have this formula, which is number of desired events over the total of number of possible events. Let's now proceed in solving a probability word problem. We follow the following steps for solving a given word problem in probability. First, the first step is to identify the experiment and the events of which we have to find the probability. Second, now we found out the number of outcomes of the experiment and every event that is determined in step 1. Third, find the probability of all events determined in step 1 using values obtained in step 2. Fourth, use probability laws to find the required probability as and when required, like the multiplication rule, Bayes' theorem, addition rule, and etc. Independent events probability. When we say independent events probability, it is an event which remains unaffected by previous event or set of events is known as an independent event. For example, tossing a coin is an independent event as each time the coin is being tossed, the result will be independent of the previous toss. If A and B are independent events, then the probability of both the events happening will be P of A and B is equal to P of A multiplied to P of B. P of A and B is equal to P of A multiplied to P of B. That is the product of probability of each event. Examples. A coin is being tossed twice. Find the probability of getting both heads. Solutions. Probability of getting a head in one toss is 0.5. The probability of getting a head in second toss is 0.5 again. Then third, the probability of getting both heads are 0.5 times 0.5 is equal to 0.250.5 times 0.5 is equal to 0.25. In words, we say that the events are mutually independent if the simultaneous occurrence probability of any finite number of the events is same as the product of their respective probabilities. Okay, that will be all.
So good day everyone. I am the one who assigned to report this topic. It all about mutually exclusive events. When we say mutually exclusive events, it is mean a set of outcomes is referred to as event. When two events cannot occur at the same time, so that time when we say that the events are mutually exclusive, then else the events are said to be not mutually exclusive. So when we say the mutually exclusive events, when the two events cannot occur at the same time. So the two events if cannot occur at the same time, that what we call is mutually exclusive event. So for example, when we flip a coin, then either heads can come or tails. Both heads and tails cannot be outcomes simultaneously. So meaning, dili siya mutually exclusive events. Dayon, example of not, let me show you the example of not mutually exclusive event is the event of getting a total of 5 or getting prime numbers on top and the experiment of throwing a pair of dice. So that example is given by mutually exclusive. So let me show you the formula. This formula means that there are two things that are clear when we see two events C, M, and N that was associated with an experiment are mutually exclusive. So look at this. 1, M, and N. So look at that. So second, the intersection set is equal to null and hence P close and open parenthesis M and N equals 0. This is because when the events cannot occur simultaneously, there can be nothing in common in them. So gets? So take a look with this number 2. Then third, the probability of union of two mutually exclusive events is given by the sum of probabilities of the events individually. So if the events are not mutually exclusive, then it is not necessary that P close and open parenthesis M and N equals 0, and hence we have that this one. Look at this one. So now let me give you an example, then I give you also the solution. So example, then solution, example, then solution. Gets? So example, from the following events, judge the pair of mutually exclusive or not mutually exclusive events and justify your answer. So I will give you the example, then Then, second, the solution. So, example, solution, example, solution. Okay. First, A. Drawing a king or an ace from a deck of cards. So, the solution of that, this set of events is mutually exclusive and we can either have an ace or king but both cannot be drawn simultaneously. So, gets? That is the solution. Then second, getting a white ball or a red ball from an of white and red balls. So solution, when we draw a ball from the of white and red balls, it can be only of one color. So again, the events here are mutually exclusive. Gets? The second is mutually exclusive. Then third, getting a number multiple of 3 and divisible by 2 when a dice is thrown. So the solution is, in this case, 6 is the number which is multiple of 3 and it also divisible by 2. Hence, we have a case that proves that the events here are not mutually exclusive. Gets? Here, this example, this solution is, or this third example is this is not a mutually exclusive. So next example, drawing a red card or a jack from a given 52 cards deck. So solution, here a jack can be read in color 2 along with black. So the events are not mutually exclusive. Gets? The events are not mutually exclusive. Then the last one example is getting 3 heads or 3 tails when 3 coins are flipped. So the solution, 3 heads or 3 tails are mutually exclusive events, as it is clear that if one occur, the second cannot occur at all. Gets? For more understanding, let me show you the example na lang din. Kamu na lang ang take a look para kamu na lang ang more understanding na lang pod. So, we are all done and mutually exclusive events. So, let's move on. The mutually inclusive events. Atong una, exclusive. Then now, inclusive events na punta. So, when we say inclusive events, probability is a prediction that an event will occur. So, probability of an event lies between 0 and 1. There are 2 types of events commonly when we talk about probability. Mutually exclusive and mutually inclusive. So, 2 siya ka types of events commonly when we talk about probability. The first is mutually exclusive events, then mutually inclusive events. So, mutually exclusive events are the ones when they cannot happen at the same time. Mauna siya ang mutually exclusive events. That is, there is no outcomes common in these events. For example, getting a head or a tail when a coin is tossed. On tossing a coin, we cannot never get head or tail together. So these 2 events are mutually exclusive. So in this case, the combined probability of 2 events can be obtained by the simply adding up the individual properties of the events. So look at this. P, then close and open parenthesis, X, U, Y, then. So look at this na lang. So, where X and Y are mutually exclusive events. So next, mutually inclusive events are the ones in which there are some common outcomes in between the given events. So when we talk about mutually inclusive events, so there are some common outcomes ba? So makabalo to siya kay ang mutually inclusive na siya common outcomes in between. So like getting an odd number or getting a prime number when we throw a dice. In these 2 events, there are common outcomes 3, 5 repeating in both the events. So these 2 events for black balls, 5, 4, 1 white and 3 black balls, 5, 4 white and 5 black balls. So solution. We know that the combination formula for selecting our items from N is, so look at the solution na lang guys. That is the solution. So number 1, we have to find the probability of selecting 2 white balls. So favorable cases will obtain when we select 2 balls from 9 white balls. This can be done in 9C2 ways. Since there are, so look at na example na lang siya guys, kay taas kay siya basta kung ano explain. Then number 2, we have to find the probability of selecting 3 white balls. So favorable cases will obtain, then we have to find the probability of selecting 4 black balls. Then we have to find the probability of selecting white and black balls. That is the solution. So murag taas-taas jud ang solution niya sa number 2. Then number 3, there are 4 men and 5 women. Find the probability of selecting 3 or which. So inato ra gyapon siya ang kuan guys, solution niya. So look at the solution na lang. We know that all the combination formula for selecting R items from in. So the same solution ra siya guys. So all the example shown to you guys is we have to find the probability. The solution is we have to find a probability. And now we are done talking about the compound probability and their illustrative examples. Now let's move on the probability distribution. When we say probability distribution, random variable na siya guys. So a random variable is a real valued function defined over the sample space of a random experiment. So the values of a random variables correspond to the outcomes of the random experiment. So discrete and continuous random variable. A random variable is a discrete if it takes only specific values in an interval. So when x takes values 1, 2, 3, 4, 5, and 6, it is a discrete variable. So when a random variable is continuous, if it takes any value in a given interval. When x takes values in the given interval, example a, b, it is a continuous variable in that interval. So let me show you to you guys. Let x be a random variable which takes values x. So the probability that the random variable x takes the value of x is defined as the probability distribution of x. So it is denoted by x. F plus an open parenthesis f. So let me show you the information to you guys. So, look at that information. So I am done with my topic. So thank you for listening, and I am Medannie tulo, and that's all about my topic. Thank you. 3-5, repeating in both the events. So these two events are mutually inclusive events. So in case of mutually inclusive events, we can evaluate the combined probability of the two events with the help of following formula. So look at this formula. That formula where P plus an open parenthesis U then MUN is the combined probability of occurrence of either M or N is a probability of occurrence of event. So look at this na lang para more understanding na lang po siya guys. Then next is when there is no common outcome between M and N, then P. So look at this. Okay, now for more understanding, let me show you the illustrative example. The best way to explain mutually exclusive event is by picking up an example, one event being even numbers we get on throwing a dice, and the second event being numbers less than 5 on throwing a dice. In the first event is called A, and the second event is called B. Then E equals close and open parenthesis 2, 4, 6, and B equals close and open parenthesis 1, 2, 3, 4. Outcome which are common to both the events are E then B equals 2, 4, and P equals 8, then equals 1/3. Examples. Which of the following events are mutually inclusive or which are not? Give reasons. So, I will give the example, then solution. First, on throwing 2 dices together, getting a sum of 4 or getting exactly 2 twos. Then solution. In this case, the events of getting a sum of sum of 4 and exactly 2 twos are mutually inclusive as the outcome. 2 and 2 is common in both. Then, second example, on tossing 2 coins together, getting exactly 2 heads or exactly 2 tails. Solution. When we toss 2 coins, we can get either 2 heads or 2 tails or other combination, but both 2 head and 2 coins cannot be occurring together. Thus, these 2 events are not mutually inclusive. Gets? Then last example, on drawing a card from a deck, getting a 2 or getting a heart. Solution. When we draw a card of a number 2 from a deck, it can also heart. This implies that these 2 events are mutually inclusive. So, mao to siya ang example o ang solution niya. Okay? Next example of illustrative example number 2. Find the probability of getting a number greater than 3 or a multiple of 2 when we throw a dice. Solution. For more understanding, so I will show you the solution of example number 2. Okay? That's the solution of example number 2. I know that all of you can get of what it's all about, mutually inclusive events and mutually exclusive events and the mga illustrative example. So now let's move on to the compound probability. When we talk compound probability, it means compound events are combination of 2 or more simple events. Example, rolling a dice is a simple event, but rolling a dice and choosing a card simultaneously is a compound event. To find the sample space and number of favorite events, organize list, 3 diagrams, or tables can be used. Combination. When we are selecting more than 1 items, we have to use combination formula to find probability. And then, combination is the number ways of selecting R items from a set of N. It is denoted by NC. So, take a look with this formula. So, nantawan ninyo ang formula, guys. Mana siya formula sa combination of probability. And then now, let's focus on the illustrative examples. Number 1. If a dice is rolled and a coin is tossed, then what is the probability of getting a head and a 6? So, solution. So, look at the solution na lang, guys. Sample space, then that is the solution of example number 1. Then example number 2, a bag contains 9 white and 6 black balls. What is the probability of selecting? 1. 2 white balls, 2. 3 white balls, 3. 4 black balls, 5. 4. 1 white and 3 black balls, 5. 4 white and 5 black balls. So, solution.